بسم الله الحمد لله والصلاة والسلام على رسول الله. الطلبة الأعزاء، السلام عليكم ورحمة الله وبركاته، وأهلا ومرحبا بكم في هذا الجزء الرابع من المحور الخامس لمادة نظرية الآلات والذي بعنوان CAM Design. Let's see here the motion analysis of the follower. So the most important thing in CAM design is something called SVAG diagrams. So S mean position, V mean velocity, A mean acceleration, and J mean jerk. This is an example of SVAJ diagram. It consists to plot position, velocity, acceleration, and jerk versus cam angle. So it is the basis of cam design. Here we have the diagram of the position. Here we have diagram of velocity, diagram of the acceleration, and finally the diagram of the jerk. Let's see RDFD cam design. It means rise, dwell, fall, dwell, cam types. So motion is between two dwells. Here we have the low dwell, and here we have the high dwell. And between the first one and the last one, we have rise phase and the fall phase. The most naive cam design is to simply connect points using a straight line here. Okay, especially in rise and fall phases. So rise and fall with a constant velocity here. So it includes, if we can see here, if the position is like that, it includes here for velocity between low dwell and rise phase. Here we have suddenly increasing for velocity. Here suddenly decrease for velocity, and here too. And velocity is constant here for all phases. So here in this region, it includes infinite acceleration and also infinite, or it's called also infinite square jerk. This design, so infinite acceleration and jerk here, this design is not acceptable. Is not acceptable mechanical cam program. As a fundamental law for cam design, one basic rule in cam design is that this motion curve must be continuous, and the first and the second derivatives, that's mean velocity and acceleration of the follower, must be finite, even at the transition points. Thus, the jerk must be finite across the entire interval. Let's see here for simple harmonic motion. Sine function has continuous derivative. If we take here the position function and do the all derivation, first derivative, second derivatives, and third derivatives, we can see here acceleration is discontinuous to pass from maximum to minimum. Acceleration is discontinuous. This is bad for design. And also jerk here is infinite. It is bad cam design too. General procedure here for design is to start with continuous curve for acceleration and integrate. Here we have a continuous function for acceleration. We integrate to the velocity. Since the velocity is equal 0 at theta equals 0, we can find out the first constant related to the velocity, and then we can find out the position function. Here we can see the continuous acceleration function. We integrate first integration to find the velocity, second integration to find the position function. We can remark here, after derivation of the acceleration, the jerk function is continuous and finite. let's see here, to completely define the function of the position, we have to find out the K2 constant. Since the position is equal 0 at theta equals 0, then K2 equals 0 here. Since the position equal h at theta equal b, then we can find out the h and the c constant here, and position, velocity, acceleration, and jerk are fully defined. This equation for a cycloid, cam has a cycloid displacement, then sinusoidal acceleration. So this cam design is valid and follows the fundamental law of cam design. Says jerk, and especially velocity and acceleration are finite, and also jerk is finite for all the period. But the acceleration and velocity here are higher than other functions.